In the last video, we learned about business statistics, what it is, and the different categories of business statistics. In this video, our goal is to learn some basic terms in business statistics. And we begin with population and sample. We would like to draw a difference between these two. Let's say that I have cooked a pot of chicken noodle soup. The reality is, because it's a pot, I am not planning on eating the whole thing. Well, if I'm interested in tasting or checking the salt content in this food I have just cooked, more likely than not, all I'm going to do is take a small part or a subset out of this whole pot to taste. This will constitute a sample from the larger population of the entire food content in the pot. So why did I decide to take a sample? Because my anticipation is that if that sample is well taken and is representative of the entire population of food in the pot, then what impression I get of the salt content from the sample should be sufficient to give me an idea of what's in the population. As much as we do this in the kitchen, we also do it in everyday lives, in businesses. Take, for example, again, if you manufacture bulbs or light bulbs, to be specific, you do not have to turn on all the light bulbs that you have ever manufactured just to get the answer to the question, what is the average lifespan of a bulb that your company manufactures? What you need to do is take a sample of light bulbs and see if you place them under experimental conditions, see how long they last. A sample is sufficient. So, based on these illustrations, we can say that the population will be the entirety or the collection or the set of all objects or individuals of interest that are pertaining to the question of interest. So, for example, if I ask, what is the average lifespan of a Toyota car? The population in that case will be all Toyota cars. Then, in order to study the entire population, we might decide, as we have established earlier, to settle for a sample drawn from that population. So what is a sample in that case? It will be a fraction, or a fractional part, or a subset of the population we are interested in studying, especially when it's impossible to study the entire population. So we take an example. In this case, we would like to identify the population and the sample. Question 1. In a survey, 100 college students at ABC College were asked how much money they spent on school supplies each year, excluding books. 3 of them answered $150, $200, and $225. Our goal is to identify the population and the sample in this case. Well, the population we are interested in here is the set of all students at ABC College and how much money they spent on school supplies each year. So our sample will be the 100 college students who were included in the survey. Question 2. A survey of 1,125 households in the United States found that 19% listened to satellite radio. What would be the population in this case? That would be all households in the United States. Whereas those who were surveyed, that is the 1,125 households that made it into the survey, will constitute the sample. With that said, we can immediately relate to the first two basic terms we use a lot in statistics. And that is the population, the entire group to which your research question applies to, and the sample, which is a subset of that population taken for the purpose of studying it to understand the characteristics of the entire population. Now, we proceed to more basic terms, and that is parameter versus statistic. You see, earlier when we talked about the entire pot, we said the entire pot has a content of chicken noodle soup. That will be the population. The chicken noodle soup content is the entire population. What about that population or the entire pot of chicken noodle soup do you want to study? There is a property of that entire pot of chicken noodle soup that you want to study, and that is the average salt content. The average salt content. That would be the parameter. So a parameter is a characteristic or property of the entire population. So if you use a number to capture this property or characteristic of the entire population, that number will constitute what we call a population parameter, or a population characteristic, or a population property. So in English, you will call it the property of the population. In statistics, we'll call it the parameter of the population. We essentially mean the same thing. And remember that whenever we cannot eat the entire population, or we cannot use up the entire population to understand the population characteristics, we take a subset of that population called the sample. If I decide to taste this sample, what comes from that sample is called a statistic. Take note, this is different from the broad area of study called statistics. A statistic is a number that captures the characteristic or property of the sample drawn from the population of interest. So, in a nutshell, for a population, whenever we define a specified characteristic of interest, we call it a population parameter, e.g., the population average or the population mean. Whereas, for a sample, whenever we want to get an idea of what the population parameter is, we can gather information from a sample. And that information we gather from the sample is called a statistic. So what is the connection between both? That is, between a parameter and a statistic. A sample statistic can provide an idea or a ballpark idea of that characteristic of the entire population when we cannot access the entire population. We take some examples in order to deepen our understanding. Identify whether the highlighted value is a statistic or a parameter. 1. Following the 2014 national midterm election, 18% of the governors of the United States were female. Take note of something here. This number captures the governors. It summarizes a characteristic that applies to governors of the entire population of the United States. So since 18% in this case pertains to all, the entire population, that number, 18%, is a population parameter. In contrast, in a national survey of 1,300 high school students, 32% of the respondents, those who responded in this survey, reported that someone had bullied them at school. So this 32%, this number, is it a parameter or is it a statistic? This is the argument for it. This is a survey, or a sample, if you will, of 1,300 high school students. Not all students in grade 9 to 12 were respondents here. So this is just a sample. And because this number, this 32%, pertains to this respondent in the sample, it is a sample statistic. Let's go ahead and take another example on page 8. A web designer for a retail store wishes to identify the average age of customers visiting the store's page. When people visit the store's page, they are invited to take a survey. 433 customers responded to the survey with an average of 29 years. So, this question will pull together all four basic ideas we have discussed so far. That is population, parameter, sample, and statistic. What is the population of interest? Take note that the goal was to identify the average age of customers visiting the store's page. So we're trying to understand a property of this group. That group, that is, all customers visiting the store's page, will constitute the entire population of interest. Whereas the characteristic of that group we want to narrow down on would be the parameter of interest. Take note, it is a parameter because it pertains to the entire population. Then the sample would be those who decided to take the survey, 433 of them. So these would be the 433 customers who responded to the survey. Then, what information did we gather from this sample? What we gathered from the 433 customers who responded was that the average age of the 433 customers is 29 years old. This would be the statistic. There are still more basic terms in statistics that we'll need to discuss. And to drive that process, let's look at this data set. Take a minute. You may pause the video if you want and look at what this data set looks like. What do you think it's about? What is the story behind this data set? What is the context? I see order number, name, state or country, price, area code, album download, is it a gift or not, stock ID, and artist. What do you think? I think that each of these are observations, as we call them in statistics. They have been observed, and you see an order number. We see the name of the person who ordered it, the state where the person is, how much was paid for the order, the area code, the album from which this was downloaded. This has to do with songs, right? Is it a gift to someone or not? No, it's not a gift. The first one is not a gift. The stock ID and the artist who sang the song. So this table is called a data table or a data set. In data science, we call it a data matrix, but it all adds up to the same thing. Each of these values here were recorded actual values of what was observed. They are all together called data. So data are the recorded actual values of the variable. Now I've just used the word variable. What are variables? Did you observe that for each song, we collected data on the order number, the name, the state or country, the price, the area code, and so on. Each of these characteristics of each of the observation is called a variable. So a variable is a characteristic or a measurement that can be determined for each member of a population. The population in this case will be all music that has been downloaded in this online directory. Take notes. Variables can be either numerical or categorical depending on what type of values you recorded for them. Take for instance, if I look at price. Price is a numerical variable. Why? The numbers that have been recorded for them can be added together, can be subtracted, and it will have meaning. In contrast, area code is a categorical variable. Why is that? Think about if you add two area codes together, 440 plus 312. Does the sum, does it have any meaning? No. So when numbers are used in this sense, this is definitely telling you that this is still a categorical variable. We'll talk more about this. Can you identify another categorical variable here? What do you think? I see gifts. Gift is another categorical variable here that immediately tells you that either this song that was bought is either a gift or not a gift. So as far as this page is concerned, We've learned what data is, what variables are, and what two types of variables we have. We are going to talk more about that. But before we move further, take note that every data only makes sense in the context in which it is collected. Newspaper journalists know that the lead paragraph of a good story should establish the 5 W's: the who in the population, or maybe it's not something animate, something inanimate, so that would be the what. When was the data collected? Where was it collected? Why was it collected? Sometimes we even have how it was collected, which we will talk about soon. So this is really important to note whenever we start talking about data. Remember, when we started, we said that statistics begins with defining a question. What is the average age of a car on an American road? Well, with that question, to answer that question, we collect data. So we are beginning to get into the raw material we need in statistics to answer questions. In the next video, we are going to probe into the different parameters with which we can classify data. Data can be classified, as you have seen, according to type in this case. But there are different parameters too under which data can be classified. This will be discussed in the next video.